to sketch the curve with polar equation r equals 1 plus 2 cosine theta, we'll first plot the Cartesian equation, treating r and theta as though they were Cartesian coordinates. R will oscillate between 3 and minus 1. Theta will go from 0 to 2 pi. There's pi. At pi over 2, r will be 1. Again, at 3 pi over 2, r will be 1. And one can easily find these points of intersection by setting r equal to 0 and then finding theta that makes cosine of theta equals minus a half. So this would be 2 pi over 3 and 4 pi over 3. Now to plot this as a polar equation. We'll start by looking at what happens when theta goes between 0 and pi over 2. That will be the curve in this first quadrant here. We see that r starts at 3 and decreases to 1. So maybe something like this. Then the next region of interest is when theta is between pi over 2 and 2 pi over 3. We see that r decreases from 1 down to 0. Then for theta between 2 pi over 3 and pi, r becomes negative and decreases to minus 1. So, because r is negative, the point will lie in the opposite quadrant. Next, for theta between pi and 4 pi over 3, r increases from minus 1 to 0. Again, because r is negative, the points will lie in the opposite quadrant to where the angle is located. Then, for theta between 4 pi over 3 and 3 pi over 2, r increases from 0 to 1. And lastly, r increases from 1 to 3. Now that's kind of a poor picture of the curve, but it does give you an idea of when r is increasing, where it's decreasing, and now we can try to suss out a better picture. Here's a graph of 1 plus 2 cos theta as our Cartesian equation. I'm going to start theta from 0 and let it increase to 2 pi, and we'll see the curve traced out. There's theta increasing from 0 to 2 pi, and you see 1 plus 2 cos theta. Next, I'm going to also plot the polar equation. Now we see the purple curve tracing out 1 plus 2 cos theta as a Cartesian equation, and the red curve tracing it out as a polar equation. And as one final addition, I'm going to add in a ray from the origin to the point that will represent the angle, and then I'll also add a dotted line for the angle in the opposite quadrant. Now, as I increase the angle, you see the curve getting traced out. There we said r decreases to 1 when theta increases to pi over 2. Now, for this portion of the curve, r is still positive. Decreases to 0 though, and then r goes negative, and so then the point is going to lie in the opposite quadrant to the angle. Hence that point lies on the dotted line. Still on the dotted line, r now increases to 0 and becomes positive again, and so the point lies on the solid line, the same quadrant as the angle.